All right, we are continuing our 6.0 study guide. We are on number 4. And number 4 says 15x minus 5y equals 30. And it's asking us to find the x and y intercepts. So I know that when I find the x and y intercepts, I'm going to use a function table. I'm going to rewrite this on another piece of paper so we can see what we're doing here. 15x minus 5y equals 30. This one is not an inequality, it's an equation. And we're going to find the x and y intercepts. So I'm going to make x 0. And that'll give me the y-intercept. And then I'm going to make y 0. And I'll find the x-intercept. So if x is 0, then this is 15 times 0 minus 5y equals 30. And 15 times 0 is just 0, so that's gone. So what's left is, now be careful, there's a negative there. It's negative 5y. See, this disappears. 15 times 0 is 15, but that negative is still there. So negative 5y equals 30. And in order to get y alone, we're going to divide by a negative number. Since it's an equation and not an inequality, I'm not concerned at all that we're dividing by a negative. Y equals, positive divided by a negative is a negative 6. So 0, comma, negative 6 is my y-intercept. Now I'm going to do my x-intercept. So I'm going to make y 0. So I'm going to write 15x minus 5 times y is now 0. So instead of y, I'm going to put 0 equals 30. Well, isn't 5 times 0 just 0? And if I have 15x and I take away nothing, isn't that just 15x? Yeah, there's a subtraction sign, but we're taking away absolutely nothing. So 15x is still 15x equals 30. In order to get x alone, we divide both sides by 15. So x equals 2 when y is 0. So I have my 2 points, 0, negative 6, and 2, 0. 0, negative 6, and 2, 0 are our two intercepts. 0, negative 6 is right here. And 2, 0 is right here. Is it an inequality? No, it's an equation, so I don't have to worry about solid or broken or shading or anything like that. So we're just going to graph it by connecting these 2 points. Now if you wanted to check that, you could put this in the slope-intercept form and graph it again and see if you get the exact same graph. I think that would be brilliant. All right, let's look at number 5, and it says graph using slope-intercept form. Remember, slope-intercept form is y equals mx plus b. But I notice that this is an inequality. So that's going to come into play when I'm graphing whether if I decide that it's a solid or broken line, or if it's shaded above or below the line. Otherwise, I'm going to graph it like usual. So since this is already in slope-intercept form, I'm going to begin at 5 on the y-axis. And my movement, my slope, it's negative 1/3, which can be down 1 over 3, or it can be up 1 and back 3. Those are both negative 1/3. So let's do this first. Down 1, 3 to the right. Down 1, 3 to the right. Down 1, 3 to the right. Or I can start here and I can go up 1 and 3 to the left. Up 1, 3 to the left. Up 1, 3 to the left. And there's my line. It's an inequality. So I have to remember, is it broken or solid? It's broken. Now, do I shade above or below the line? Well, it's less than, so I should shade below the line, and it's in slope-intercept form, so that's good, because above the line and below the line works when it's in slope-intercept form. So less than is below the line. We're good. We just shaded our inequality. We're totally good. Now, number 6, again, we're using slope-intercept form. Please notice this is in standard form, and it said put it in slope-intercept form. So the very first thing I'm going to do is put this in slope-intercept form. So I have 15 minus 5y is greater than 10x. Well, if I'm going to put this in slope-intercept form is y equals mx plus b. I have to get my y alone, don't I? And of course it's an inequality, so I'm going to do my fish hooks, and I'm going to do my random rule just in case, and I'm going to try to isolate y. So I'm going to come up here, and here's where my y term is, and I want it alone, so I have to get rid of 15, so I'm going to do this. Notice that the x is already on the right hand side. It's the constant that we're moving this time. These cancel out, and I'm left with negative 5y. And over here, I want my x term first, so I'm going to bring down my positive 10x, and then I'm going to bring down my negative 15. Now I want y alone, so I'm going to divide every stinking term by negative 5. So these cancel out, and I'm left with y. 10 divided by negative 5 is negative 2x. A negative divided by a negative is a positive 3. Look what we did. We divided every stinking term by a negative number, so we're going to flip our inequality symbol. Now it's in slope-intercept form. I need it to be in slope-intercept form when I decide where to shade it. Less than is below the line, and greater than is above the line, and that only works when it's in slope-intercept form. And mine is in slope-intercept form. So we're going to graph y is less than negative 2x plus 3. That's what happened when we put it in slope-intercept form. Now look at this. When it started, this was the symbol. But when we put it in slope-intercept form, the symbol's different. So our shading is going to be different here than it would have been here. That's why it's important to put it in slope-intercept form before you shade it when it's an inequality. So I'm going to begin at positive 3 on the y-axis, which is right here, and my movement is going to be down 2 and over 1, down 2 over 1, down 2 over 1. My line is broken because it's not equal to, it's only less than. And since it's less than and it's in slope-intercept form, I'm going to shade it below the line. And that's number 6. So that takes care of your entire homework except for 4. Number 2 was graphed using a function table. Show how you would graph the same equation using x and y intercepts and slope-intercept form. So look at number 2. We used a function table, didn't we? And we used 3 random values for x. So now we're going to graph it again, this time using the x and y intercepts. So we have 2x plus y equals 1. We already graphed it using the 3 random values for x and a function table. We're still going to use a function table. We're going to make x 0, and then we're going to make y 0. So if x is 0, Well, 2 times x is 0, so positive y is 1. X is 0, y is 1. Now we're going to make y 0, so we're going to plug in 2x. Wait, plus 0, well, there's that. If I add nothing to 2x, I just get 2x, don't I? So 2x equals 1. If I want to get x alone, I divide by 2. X equals 1/2. I have 2 points. I'm going to graph them. Let's see, when I graphed that before, I had -2, 5. We had, when we first graphed it with the first function table, we had -2, 5, and then we had 0, 1, and then we had 2, -3. And now we're going to graph it using the x and y intercepts, which are 0, 1, which we already had, and 1/2, 0. Well, if x is 1/2 and y is 0, x is 1/2 and y is 0, that's a point right there. So when we graphed it using our x and y intercepts, it was the same line that it was when we graphed it using our function table with 3 random values for x. So we graphed it 2 ways. Now the third way is to put it in slope-intercept form. So we have 2x plus y equals 1. Remember, this is number 2. We're graphing it 3 different ways. I want to get y alone. I'm going to subtract 2x from both sides, and y equals -2x plus 1. Well, that was easy. So we add 1 on the y-axis, plus 1, and -2x means we go down 2 over 1, down 2 over 1. It's the same stinking line.